DS30 podcast. My name is Ana Hocevar, and today I am going to be chatting with Rohith Desikan, who is a software and data engineer at Weavegrid, also a data incubator alumni. And he will talk to me about, I'll do it again. Hello and welcome to another episode of the DS30 podcast. My name is Ana Hocevar, and today I will be speaking to Rohith Desikan, who is a software and data engineer at Weavegrid. Rohith has a particular interest in the intersection of machine learning and sustainability, and he will talk to me about everything from machine learning in production to some very cool database system solutions that they found. So let's jump right in. Hi, Rohith. Thank you so much for talking to me today.
Of course, nice to be here.
So we usually like to start an episode of our podcast by getting to know our guest a bit more. So I'd be curious to know a little bit more about you, I guess in particular about your background and how you got into data science.
Sure. So the first time I did anything with data, anything related to data was my internship in grad school. My internship was at the US Green Building Council in DC, and they work on essentially certifying green buildings, basically. Figuring out whether buildings are green and giving them a rating, and they're pretty popular in the sustainable industry. And my graduate studies were extremely diverse, and they sort of spanned all the elements of sustainability. And when I joined this team, I was on the real estate team. So I was analyzing portfolio level sustainability action data from real estate companies. And we took all that data and we ranked them in environmental, social, governance metrics. And it was pretty much a simple data analysis task, but it was still one of the most interesting things I'd ever done, because just a little bit of data analysis and digging led us to areas, and it led us to insights that we never would have had otherwise, that we didn't even know existed. So I think that it was like magic. It was like finding gold. It was like, oh, what is? I didn't know that existed, right?
Yeah.
And so that's when I really got interested in this. And a little bit of research quickly led me to machine learning. And the very next quarter, I went back to Stanford and took the famous CS 229 with Andrew Ng, which is still the most difficult class I've ever done, but also one of the most rewarding. Because by the end of the quarter, I'd sort of understood what machine learning was all about, and we did a final project where we predicted the optimal retrofit for a school building for 3,000 schools in California. Another project that I was blown away by what I was capable of. So then that's when I joined. Once I graduated, I joined Affiliated Engineers to sort of bring this data knowledge to the clean tech and climate tech space where I plan to be.
Mm-hmm. Very nice. And so you're currently at Weavegrid. So maybe you can tell us a little bit more about what Weavegrid does first.
Sure. So Weavegrid's essentially builds software and machine learning to help intelligently connect electric vehicles to the grid. Now, let's break that down a little bit, so kind of open-ended. So we all know that there's a massive shift happening towards EVs. And it seems like every month a different car company is pledging to go all electric fleet by 2035 or 2040 or whatever that is, right? I think it was GM that was the latest one. So this decade will see an exponential adoption of electric vehicles. Now, the question is, can the grid actually handle the sheer volume of electric vehicles that will need to be charged? And if all the electric vehicles are being charged at the same time, that's going to cause an immense strain on the grid. So it matters how we connect these electric vehicles to the grid. It matters when they're going to charge. And that's the problem that Weavegrid is solving. Is we sell a software and machine learning product to utility customers to help them monitor and manage their electric vehicle fleet.
Cool. And was it something in particular about Weavegrid or this particular position that kind of attracted you to it? Was there a reason why you joined?
Yeah, I mean, I was looking for three specific things for at my next role. I've known about Weavegrid for a long time. I'm friendly with a few people here, but more generally, I wanted a place where I could just learn by doing. And one of the best ways to learn rapidly by doing is to join a startup. This is one of those things that's especially true at a startup, and it has been true so far. I wanted to work on a job that was more than just data science. That's the second thing. It's I wanted I'm sort of a big picture person, and I need to understand how one component fits with the rest of the system to really gain an understanding. And that's what I wanted. So I wanted to work on other aspects of the software stack. In fact, so far in about 4 or 5 months that I've been here, I've done very little machine learning. Most of it we're an early stage company, and most of it has been just building out core software and infrastructure, which is great. And the
Yeah.
third thing that I wanted was to work with a fantastic team. And Weavegrid, so far, we have fortunately managed to put together an incredibly experienced and just unbelievably talented team. So it's been incredible to work with the people here.
That's great. So what you were just saying kind of ties to the things that I mainly wanted to talk to you about. So when you were saying that you'd like to know how a piece fits into the whole story, basically, right? Where a data scientist might be focused on just developing that machine learning model, but how do you actually make use of that, right? There's so much more that goes into, of course, that just preparing that. And then, of course, obviously, kind of all the infrastructure for model deployment and that whole thing. But maybe I want to first focus on kind of how your current role expands on kind of or sees this bigger picture of this whole story of making use of I guess data science solutions in some sense. So I understand your current role focuses on database systems and finding clever solutions in on that kind of in that end. Can you tell me a little bit more about that?
Of course. I mean, first, I would like we can talk a little bit about like how I actually went from TDI to Weavegrid, because that's a
Hmm.
kind of an
Absolutely.
interesting
Yeah.
journey in itself. So I mean, I graduated from TDI 2 years ago now. So that was this is which is a lot already, but it was an extremely valuable experience. And the thing is that I gained a lot of practical knowledge that I didn't have before. In coming out of school, I had the academic and theoretical knowledge, and then at TDI, I learned how to apply machine learning in a business setting. How do you make sure that that model that you build has business value, right? And then how do you actually build it, do the modeling in a reproducible way? So those were the things that I learned at TDI, and then I went from TDI to sort of applying that uh, at my previous company, Affiliated Engineers, and AEI is a sustainable building design consulting company. They offer everything from like mechanical engineering services and to sustainability consulting for large campuses, whether corporate or college campuses. And that was my focus. So these campuses would come to us and they would say, "Oh, we want to be carbon neutral by 2035 or 2040. How do we achieve that?" And we would essentially take their sort of IoT data from all of their buildings, so their all of their water consumption and their electricity consumption, and we would essentially do some level of anomaly detection and remove do a lot of time series analysis, a lot of visualization, because a whole aspect of doing this data science is visualizing it back to our clients. Then we built forecasting models to depending on how their campus was going to grow. So we have their data right now, and by 2035, this campus expects to grow by 10%. They expect 2 new office buildings, 1 new gym, and 1 new lab building, or whatever, or like a couple of residences, or whatever the situation is. So then we would apply these forecasting models to those specific kinds of to specific buildings, and we would forecast a future load. And then, all right, this is your future demand. This is how, and here is a system that we've designed that can meet said demand. And it was in the last 6 months at my job there, around this time last year, that I was building out a lot of ETL pipelines. I had sort of gone through this project once, and then I saw that, okay, we need to build reliable ETL pipelines to ingest weather data, this kind of IoT data from our clients. So now I sort of built a few of these robust data pipelines, and it just taught me the importance of that aspect of machine learning as well. I'd spent far too long doing that the first time around, so I was able to speed it up the next time.
Uh-huh. Yeah, very good. And then when you joined Weavegrid, then you mentioned before that you didn't spend so much time actually building machine learning models in the last couple of months, but as you say, you're kind of working on clever database design, should we call it?
Yeah, yeah. So that's super interesting because it's kind of very specific to the problems that we're facing. So here's the issue. Our customers send us static data that on some regular interval. Some of them send it daily or every few days. And the issue is that we are selling a product to an industry that is highly, highly regulated. And the utility customers or utility companies around the US are basically regulated monopolies. And there are rules governing everything, and especially on data, right? On data security. So given the fact that this is a legacy industry, data security was extremely important to them. So for us, security was a top priority. Essentially, like a breach into one customer's database cannot pollute another. So it's essentially a question of how do we separate this data in a reasonable form. And there's a few different things to consider here. So security, like I mentioned, but also how do we maintain all of this data, right? How do we, if there are bugs later on, how do we fix them? How do we perform analytics and monitoring? How do we actually monitor the database to make sure that it's performing like we want it to? So before, I think this still exists now, but beforehand, there used to be all a database administrator, right? That used to treat the database like their own baby, and they used to take care of it, make sure that it was monitored properly, make sure that the scaling and maintenance and security updates, all that stuff was sort of there would be a person to take care of it at a really, really large company. However, the good thing is that these days we don't need that anymore. I know I've sort of, and for our problems specifically, we noticed that all of our schema across all of our customers was going to be the same. And there were going to be few changes on that. And we just ended up with this crazy solution that's very specific to us. We have separate databases completely for each of our customers. So we have separate Aurora, serverless, Postgres databases for each customer.
Interesting. Is there so I think you mentioned kind of the requirements, I guess, that kind of led you to that to kind of, I guess, solution. But I still wonder, how did you think of that? Like, how did people? It's not as usual, right?
Right. It's definitely not. The first thing we needed was we just chose Postgres as a SQL engine and the database design because it specifically worked for coordinates that worked for us. So, and it's sort of the best one we have. And then within Postgres, we can sort of separate data in various ways. I think one of the reasons why we tended towards these separate clusters entirely was because it was like we can just blow all the security requirements out of the water. We don't ever have to worry about this again. if we just do this here, we just say that your data has absolutely nothing to do with any other customer's data. Here you go. That's one headache that we don't have to deal with anymore. But the good thing is that now AWS provides a new service called Aurora Serverless, right? And
Hmm.
uh,
So
it's the
maybe we
server.
can. Sorry to interrupt you. Maybe we can just mention that for any of our viewers who might not be familiar with the term. Or so I guess people imagine that like database is like this thing somewhere holding my data, and then if it's a
Yeah,
SQL database, oh, I've heard of that before too.
right,
But maybe
right.
can you tell us a little bit about how kind of that works?
Of course, yeah. Um, like I said before, there used to be a database administrator that sits and manages this data, right? But the good thing with Aurora Serverless is that we don't have to do that anymore. We don't. No one has to sit and manage the maintenance, scaling, uptime, security updates. None of this. We don't have to worry about any of this anymore, and AWS takes care of it on the back end, right? We don't have to, for example, when a database is receiving a large number of requests, you have to sort of scale it up and then scale it down when it's not being used. All of this happens automatically on the back end now using Aurora Serverless, which was an incredible sort of gift to us because we could simultaneously serve our security requirements while also enjoying a low maintenance database environment. We could always just assume that so long as AWS is up, the database is going to be up and running, and that gives us, yeah,
Yeah.
that's really good for us.
And so, did I understand correctly that your kind of solution to have a designated database for every customer was um, mainly driven by the security aspect? Is that a correct conclusion?
That's correct. Yes, but
Hmm.
it's also turned out to be surprisingly easy to manage. I had the same concerns before I did this. I was like, this is going to be an absolute mess to build and maintain. But to actually build out the resources, it's to actually spin up the infrastructure. It's also very easy because we at Weavegrid we just use Terraform to build out all of our infrastructure. And just to explain what that is, Terraform is basically just a simple way to spin up or destroy cloud resources. Essentially, like instead of going and clicking on the AWS console, you can just write a script and it'll spin up whatever resources that you need on the cloud, and it works for Google or Azure or AWS. And I think using a combination of these technologies has made it such that it's sort of very low maintenance on our end.
Hmm. Hmm. I have a question that kind of ties back to when you were telling me about your background and how you got into this particular position and kind of your curiosity, I guess, for the bigger picture of the whole pipeline of this kind of goes into a product. Do you, how did you, for anyone who might be interested in that as well, but might feel like, wait, but I don't have any like database experience, or I build machine learning models. How could I do a little bit more of that data engineering component? Do you have any advice, or kind of how did you jump into that? Did you just kind of just try? Did you just learn it on your own? Was it working on the job, learning on the job?
Right. Um, I think one was when I first got into this was at my previous company at Affiliated Engineers, and that's when I just recognized the need for this. Right, I just recognized the need for a building reliable data pipelines, and it was because we were getting all this time series data from our customers, and I didn't want to. No one wants to sit around and sort of do the same thing again. So I sort of had a need for these kind of ETL processes. So if there's machine learning engineers out there like looking to gain knowledge in this area, there is a need at whatever company you're at. There is a need to build out a reliable data ingestion pipeline, because otherwise, like your machine learning model, ML doesn't work unless the core software and infrastructure works. So there's always an opportunity to improve that data pipeline, make it quicker, make it easier to monitor, make it more reliable, make it more extensible for newer customers, for example. So
Yeah, yeah, definitely. And that actually ties to a kind of another I guess, topic that I wanted to dip our toes into, which is the ML in production, kind of, right, where it's not just an isolated thing of I'm building this machine learning model and it seems to work well, so now I'm done, right? But as you say, it's this whole thing before, as in how data feeds into that, if you will, right? So all of that ETL pipeline, but then also actually putting in production in the sense of deploying the model and all of that. So I was hoping if maybe we could do a little kind of bigger picture view of that whole process, tying back to what you were mentioning before. So for anyone who might not be as familiar with what do I mean when I say, so this ties into machine learning in production, like what does that mean? I know.
Of course. So a classic case of machine learning in production is a recommendation algorithm, right? This is a pretty good example because when you go on Amazon and you look for some item, soon enough you'll see people who bought this also bought this, and that's an example potentially of a recommendation algorithm. So ML in production means that the machine learning model that is built, that you built somewhere in some Jupyter notebook or something, it is now serving predictions in real time to fill out the you may also like section of your Amazon shopping cart. So that is an example of how your ML actually works in the real world, and that's where we as Weavegrid want to get to, and that's where the industry is sort of moving as well. It's moving to focus heavily on making sure that machine learning models operate in production, operate in the real world on a real website or and generating real value for a customer.
Yeah, yeah. And there's, I guess, different parts that go into that, right? How do I get there from my either Jupyter notebook or some code, some script that I wrote, running some Python, it does some machine learning, the model's performing, right? There's kind of other components that go into it being live and like actually serving predictions.
Absolutely. One way to do that, at least sort of extending from what Weavegrid has used for our base software infrastructure, is microservices. So at Weavegrid, we use microservices for everything. We're a fully microservice environment, and we essentially have, and a big component of a microservice environment is APIs. So we're just building APIs that can sort of communicate between every single one of our microservices. And the way we split up our services is, of course, a question that is dependent on the company and dependent on the business needs. So we split it up one way, and we essentially just use a Python package called Fast API to build out all these packages. And Fast API is kind of just a quick aside on Fast API. It's super new. It's only been around for about 2 years, but it's the next iteration of Flask. So I personally learned Flask at TDI, and I thought it was awesome. And Fast API is like taking it to the next level, because with Flask you have to download a bunch of additional packages like Flask SQL Alchemy or Flask for that's for database connections, or Flask login, for example, to manage your user login if you need it. But Fast API essentially brings a whole bunch of stuff under one umbrella, and it allows for really good documentation, really good logging. It's really easy to build tests with Fast API, and so we saw like a 5x benefit over Flask and some of the other tools that we were using. So most of our microservices run in Fast API now. They communicate through that, and our machine learning models will also communicate through the same through this kind of API layer, right? Essentially, we build it. Once we build a machine learning model, it would sort of it would be like serialized, and it would live somewhere, and then the predict function would just sort of call that serialized model through, and that data would be communicated via these APIs to our front end application.
Yeah, yeah, very cool. It's funny, can you mention Fast? So I've only played around with Fast API a little bit, so I'm more of a Flask person. But I did ran across it at some point, maybe like half a year ago ish. And then like I made like a simple, I was like, okay, I'm gonna make a simple app, kind of like what I would in Flask. And it's very interesting what you're saying. I also actually really liked it. I mean, I did not use kind of all of the full capacity where I would feel like you're saying, oh, this is 5 times better or whatever. What I did feel though was that the name is too similar to Fast AI. And whenever I was like Googling, oh, how do I like whatever, Fast API, I'm getting whatever error, I kept like this spelling it and Googling Fast AI. So yeah, very cool. I'm conscious of the time, but we are sort of almost running out of time. So I want to make sure to kind of circle back to Weavegrid, and I wanted to ask you a little bit about kind of where Weavegrid is at the moment, where it's going, and I know that you will be hiring in the future. So kind of what is Weavegrid looking for?
So we were just looking for something pretty. Our requirements are actually pretty simple, right? We're looking for people with some level of data science and machine learning and software experience to get their hands dirty, just writing clean and productionized code. So this is not even a future data scientist that we hire is not a Jupyter Notebook style job. And that unfortunately just doesn't cut it. We need the ability to write production code because that allows us to iterate faster and it allows us to sort of build our product out faster. And so that is absolutely crucial for us as we hire more and more software engineers and data scientists. In fact, right now, I think 6 of our 8 engineers have some background in machine learning, including myself. And we're all just focused on building out software infrastructure at the moment. So there's no shortage of machine learning knowledge, but we need every new person to be able to understand infrastructure and push code to production.
Yeah, yeah. Kind of ties to everything we were just talking about. Yeah. How it's all of that that's just so important to really.
Exactly.
So with Weavegrid sort of having this emphasis or focus or kind of the main important being ML in production, what does the landscape there look like?
Right. So the first thing we've already talked about building ETL and or ELT pipelines in a reproducible way. Most of that is kind of company specific and problem specific. Now, once we get into the actual model development process, there's lots of tools now that can simplify and improve the model development process. We've got all the big cloud providers have auto ML services, hyperparameter tuning. There's so many of those kits now. ML flow is essentially used to track models and used to version models. And then there's numerous companies here that are working on simplifying model versioning and model deployment, like Algorithmia, Data Robot, or something. So there's lots of companies that do this. However, now there's an interesting concept that's also coming up called a feature store, right? Which is essentially you store your features in a plug and play like system. Your features essentially act as your database, and a data scientist can just go and pluck out the features that they need to test their model. Because right now, so the feature development and feature engineering, which is a very difficult part of machine learning that we don't get unless we do trial and error, that aspect of model development is no longer living in a silo. And we essentially get a single window into understanding what features we have, like as a nice catalog, basically. We understand that, of course, we have to understand that these features have to be updated on a regular basis, and there's a lot of work in actually maintaining it. But the features are not maintained in raw form; they're maintained in featureized form. So they're maintained as a feature store is maintained in it's just numbers, basically. An image is maintained as pixel data, not as a JPEG file. And there's a few companies that work on this, so like Tecton AI or Iguazio, as a few companies. I have no affiliation to any of these companies. This is just like there's a lot of people working on this stuff, right? Another thing is the issue of CI/CD for ML. So CI/CD for software is very easy. Well, at least now it's very easy with Circle CI because you write code, you write unit tests, and you make sure those unit tests work on your CI platform. But with ML, it's not just about the code. You have to make sure the data is consistent as well. It's a question of data versioning. And you can't just check in a massive database into Git, even though DVC, or data version control, is trying to do something like that. And there's no good solution for this yet. And then there's the issue of model explainability, which is going to be very crucial for us. We're selling a software product to utility customers. They want to know how and why we came to a certain decision. So a black box model is not going to work unless we're able to tie a specific training example to a specific result. And model explainability is getting more and more hype these days, with whether we're using causal inference techniques or there's a company I think called Fiddler.ai that works on this. And then comes ML ops and ML deployment. So this is where all that infrastructure knowledge that we talked about before is going to, and this is where it's going to live, and how is it going to serve predictions. And now the question is like reliability, monitoring, and the models. All machine learning models will degrade over time. That's like it's like entropy. Entropy will increase. Your machine learning models will degrade over time because your type and your style of data will change. Data drift, business or KPI, key performance indicator drift, or mathematical drift. Any of these drifts could happen, which means your model will degrade. Now, there's a few companies that are working on scaling machine learning, like OctoML or Cortex ML. They sort of help model deployment and scale your ML models in production. And then finally, once your model is degrading, how do you detect it? And how do you figure out what training examples have caused that model drift so that you can retrain your model? Because that feedback loop has to be closed. You can't just throw the model into production and just call it quits. That feedback loop has to be closed. And there's not too many players working on that. And it's only recently, at least over the last year, that I've gotten very interested in ML ops. And I've started following the space very closely now because that's where the industry focus is. A newsletter that I follow is the ML Ops Roundup. Full disclosure, it's not mine, but it's a really good bi-weekly newsletter.
Nice.
That discusses exactly these issues and gives a good roundup of the industry.
Awesome.
Yeah.
That's great. So we are out of time. Rohith, it's been absolutely a pleasure.
Thank you very much. Thank you for having me.
Thank you so much.